Hey there, let's tackle a stoichiometry problem involving a limiting reagent. In this type of problem, we use a balanced chemical equation to determine how much product can form from a given amount of reactants. Now, both reactants are present, but one will run out first, and that's the limiting reagent, and it determines how much product we can actually get. So, when 8 grams of N₂H₄ and 92 grams of N₂O₄ are mixed together and react according to the equation below, what is the maximum mass of H2O that can be produced? So we were given the grams for each reagent, and we were given the molar mass. We were also given the equation, but this equation isn't balanced. So if you notice, we have 4 nitrogens on the left side, but only 2 on the right. We also have 4 hydrogens on the left side, but only 2 on the right. So we'll need to balance this equation before we can move forward. So I like to set up my equations like this. And the first thing we can go through is identify how many of each reagent we have on either side. So for my nitrogens, I have 4 of them on the left. And we've got 2 on the right. And then with our hydrogens, I've got 4 here and 2 over here. And then with my oxygens, I have 4 on the left and 1 on the right. So what we need to do is add coefficients in order to make both sides equal. So I'm going to start actually with my oxygen. And so I'm going to add a 4 here, right? And actually I'm going to use a different color so we can kind of follow that along. I'm going to change that to red. I'm going to add a 4 here. And what that does is it changes that number of oxygens because the coefficient applies to every atom within the given molecule. So now I have 4 oxygen on this side, and I have 4 times 2, this subscript for my H. I actually have 8 hydrogen now. And now let's take a look at the opposite side. So over here, we also want to have 8 hydrogen. So we know the oxygen, we've got that is balancing out so far. So if I want 8, I'm going to add a coefficient in front of this N₂H₄. So that's going to give me 2 times the 4H is going to give me 8 hydrogen on that side. So that's great, we have that. But now let's reevaluate how many nitrogen we have on either side. So now I have 2 times 2, which is 4, plus this 2 over here, that gives me 6, right? So I have 6 on this side actually now. And so I have only 2 on this side. So if I add a 3 as my coefficient, then that changes that to 6 on the right side. So now my equation is balanced. So we can move on to the next step. So now what we want to do is convert our grams to moles. So we know that molecular weight is equal to our grams per mole. So if I know how many grams I have in the molecular weight, I can solve for moles using this equation here. Now, if we notice, it was given to us the grams and molar mass in the original equation. So all we really have to do is plug those values in. And what we're left with is 0.25 moles for the N₂H₄ and 1 mole for the N₂O₄. Perfect. So now we can move on to step 3. So here we are ready to identify our limiting reagent. So we're going to go back to our balanced chemical equation. And if we notice the ratio between our reagents, it's 2 to 1, right? For every 2 moles of N₂H₄, that reacts with 1 mole of N₂O₄. We have this ratio of 2 to 1. And so because we have, remember from our last question, 0.25 moles of N₂H₄ and 1 mole of N₂O₄, in order for all of this N₂H₄ to react, we only need half as much of the N₂O₄, which is 0.125 moles. But we have 1 mole of that reactant, so we have an excess of it. So that means in this reaction, all of the N₂H₄ is going to get consumed, and we're going to have some N₂O₄ left over. So because of that, we can identify our N₂H₄ as our limiting reagent. Let's move on to step 4. So now what we can do is use the mole ratio from that balanced equation to find the moles of H2O. So now I'm interested in, okay, this is my limiting reagent, and I want to figure out how much H2O will be produced, how many moles. So for every 2 moles of N₂H₄ that's consumed, we get 4 moles of H2O produced. So we know that what we have present is 0.25 moles of N₂H₄. So we can plug in our mole ratio between my reactant and my product to kind of convert. So what I'll do is I'll multiply and divide these out. And basically this is going to cancel out my N₂H₄ on either side. So I'm left with moles of H2O. And from there, once that's solved, we have 0.5 moles of H2O present. So now what we want to do is convert those moles of H2O to grams. And we're going to go back to that same equation. Remember, molecular weight equals grams per mole. So if I know the molecular weight, I know how many moles I have, I can solve for grams. Now, to determine the molecular weight of water, because they didn't give that to us in the original problem, we can just use our periodic table to find the atomic masses for each of our atoms in this molecule and add them together to get the overall molar mass. So we have hydrogen, and I've rounded these to the nearest whole number just for simplicity, but we have hydrogen with 1 gram per mole and oxygen 16. We have 2 hydrogen in the water, so that gives us a total of 18 grams per mole. So then same thing as before, we're going to plug those values in. We already determined the moles of water from the previous step. So now we're left with 9 grams of water. So this is a max amount of water that can be produced from the amount of reactants that we started with. Now, this was showing you step by step the logic and the processing of how we go from point A to point B. But there is a bit of a simpler method called dimensional analysis. This is a quicker way. So really what you need to have is the balanced equation, and then just clearly identify what it is you're trying to get and what it is you already know. So we have the balanced equation. We want to convert from grams of N₂H₄ to grams of H2O. We know what the molar mass is for each of these, the reactant and our product, and we know what the ratio is from our balanced equation. So we actually can set this up in a series of conversions that will allow us to quickly get to our answer. And you can follow along as it cancels each of those out, ending up with our grams of H2O. So this is the quicker method to get to the final answer, but you'll be able to understand the logic and what's happening at each one of these steps. So thanks so much. Hope that helped.